Okay, calculus, let's talk through two 9.8 homework examples. We'll do 1A and 2B. The only ones after that are kind of classic cases. I will say 3, the second B, because it's 3B and 3B, is a little more conceptual, but still easily doable. So 1A says find the radius of convergence for the sum from n equals 0 to infinity of -1 to the n times x plus 1 to the n over 5 to the n. Now, there are two ways you can look at this, but we're just going to do the way we use the ratio test. Remember, when you use the ratio test, you do the absolute value, so the -1 is gone. So we take the limit as n goes to infinity of x plus 1 to the n plus 1 divided by 5 to the n plus 1 over x plus 1 to the n over 5 to the n. Of course, you multiply by the reciprocal. What I did here was I also paired the terms. So I put the x plus 1s together and the 5s together. And so all the x plus 1s cancel except for 1. All the 5s cancel except for 1 in the denominator. So we have the limit as n goes to infinity of x plus 1 over 5. Now, of course, to get convergence for the ratio test, you need to be between -1 and 1. Because the absolute value has to be between 1 and -1 and 1, or 0 and 1. But that means x can go out 5 on either side from -1 to get there. So the radius is really just 5, basically, because of this. You know, x can go out 5 on either side because it's divided by 5 to stay between 1 and -1. Now this becomes a little more clear if we talk about 2b when we're doing the interval of convergence, which is usually what you do. Radius is important, but interval usually encompasses radius already. So if we have 2b, which is the sum from n equals 0 to infinity of x minus 3 to the n plus 1 divided by n plus 1 times 4 to the n plus 1. This means we have this huge dividing the n plus 1 term by the n term. So x minus 3 to the n plus 2 over n plus 2 times 4 to the n plus 2 divided by x plus 3 to the n plus 1 for n plus 1 times 4 to the n plus 1. So again, just like I did up here, I'm going to pair my terms. There's an x plus minus 3 to the n plus 2 divided by an x minus 3 to the n plus 1. That'll cancel out to x minus 3. Remember, the denominators down here go to the numerator, so I'll have an n plus 1 divided by an n plus 2. Nothing cancels there, but when we take the limit, it'll be apparent what that goes to. And we have a 4 to the n plus 1, which will flip up to the numerator, divided by a 4 to the n plus 2, which will leave a 1/4. Now, when we take the limit, n plus 1 over n plus 2 is going to go to 1, which means I have the rest of these two numbers, x minus 3 and divided by 4. That's the numbers that are going to determine if I'm between -1 and 1. And the over 4 is a constant, so if these are between -1 and 1, that means -4 is less than x minus 3, which is less than 4. If I add 3 to both sides, -1 is less than x is less than 7. Now that gives us all the data on the inside. We still do need to check the endpoints to see if they're included or not. So let's look at what happens when we plug in 7 for x. 7 minus 3 from up here is 4. So this becomes 4 to the n plus 1. But compared to this 4 to the n plus 1, these two are going to cancel, which leaves just 1 over n plus 1. And we know this is basically p-series, and it diverges. Now what happens if we plug in the other endpoint, -1? So that means 7 isn't included. If we plug in -1, instead of positive 4 to the n plus 1, it's -4 to the n plus 1. Now, for -4 to the n plus 1, I can break that into two pieces. That's -1 to the n plus 1 times 4 to the n plus 1. So if you're wondering how I got to this, I just broke off the -1 and the 4 and let the two 4s cancel, and then all that was left was the -1 to the n plus 1, divided by n plus 1. Now, we know this one is different than this one because this is alternating, and the rules for alternating series tests is, are the terms alternating? Yes. And are the terms going to 0? The limit as this goes to infinity is 0, which if you satisfy those two, then it converges, which means -1 will actually be included. So that means the interval of convergence is -1 to 7 with -1 included in that interval. Okay, we'll also do 9.9 today, and that'll be next.